So, Mr. Davenport, thank you very much for this very interesting lecture. At the beginning of your presentation, you mentioned the outsider's view as thinking about the mathematical notations as completely precise and well determined. But honestly speaking, I think that most of the mathematicians think about the notations in their special field as absolutely unique and well determined. So what I want to ask that is it intentional to push us means mathematicians, out of our comfort zone with this lecture, to recognize, to make it clear that it is not so obvious, not so unique, and not so well determined?
It wasn't my primary intention to push people out of their comfort zone, but I did want to explain to mathematicians why it is their problem is a bit harder than they think it is. Because for any given mathematician, he knows what he means. But the mathematician in the next office working on something different will mean something different by the same notation, but they all want a solution. And they cannot all have the same solution. So yes, in the sense of challenging mathematicians to understand that their problem is harder than they think, because each one has their own problem. They don't all have the same problem. They want to understand notation, but my notation is not your notation. So in fact, it is like asking for a universal translator rather than just a translator. And there are these differences. And each mathematician is used to his or her own subject's notation. But it is a real challenge, one that we probably do not appreciate enough, that our students who come in have to learn these notations. And as I said in my lecture, when you have blind students or students for whom you have to produce lecture notes because they cannot tell something apart or something like that, you are really forced to examine your notation more carefully than most of us do. And most of us, for example, if I take the example of the Landau notation, we who use it in our daily thinking use it quite happily. We don't worry about the fact that the equal sign means something different in it and so on. But for 5 years, I have taught students who are learning this for the first time, and they do find it genuinely difficult. The mathematicians actually made a mistake here. We chose the wrong notation. It works for us because we're used to it, but it's not a good idea. Just as in the English language, some choices are made about spelling words, which are not helpful to the newcomer learning English. English spelling is awful because it is the history of 500 years of choices, most of which are good, some of which are bad. And the same is true of mathematical notation. There are some choices which are, as I said, frankly bad. And there are some choices which actually do our students no favor. We could actually make our subject not much easier, but just a little bit easier to understand and to read even if we made some slightly different choices. These are fine-tuning, they're worth doing. And they do mean that our notation is more ambiguous than it need to be. We are used to it. We fresh mathematicians are used to it. So yes, I am, I suppose, standing back a bit and challenging the mathematicians. Have you really thought about what that conveys?
Okay, thank you. What I've learned from your presentation is that in the United States, it is a serious problem in terms of Hispano-Americans.
Yes.
Do you have similar experiences maybe with immigrants at your university or in Great Britain in general?
I haven't encountered a similar problem to the same extent. One problem I do encounter is that more in computing than mathematics is that students who come from, say, China are not used to the difference we make between upper and lower case. They just think I'm drawing a letter bigger. They do not appreciate, as we do, and worse, as computers do, these are different symbols. They are, to the Chinese student, they are just variations on the same. And that is a problem I find in computing quite a lot, that the students are not used to making that difference. In mathematics, I do not see so many, but I I have heard from teachers of mathematics in primary schools in England that there are unsolved problems with immigrant communities that they haven't got as far as solving as that American example I showed you, where at least the teachers have a clear sheet explaining to them side by side what the differences are. But it would be much better if a teacher had a piece of software which could display the same calculation in either notation. And that's what we can now do with MathML, or indeed, as I said, 10 different notations for division. But yes, and I didn't mention this, I did trip up over it. I was teaching algebra in France. I was doing division of polynomials. And I said, you do it the same way as you divide numbers. And I did it my way, and none of them understood me. I had to get a student to divide two numbers the French way, and then I could tell them how to divide polynomials the French way. So even at this was at university, I actually tripped across the same problem because I was generalizing on something they didn't know. So it is a real problem. It's a bigger problem than we think, and thank you for reminding me of that. Thank you.
Thank you. Last question. Although to less extent, but I think it is a problem also in computer science. For example, in programming, when you have an incremental procedure and you say n equals n plus 1 or something. Yes. Do you have similar experiences in computer science as well?
Oh, yes, that's a good question. So, Ruttishauser, back in the early days of Algol 58, before even Algol 60, wanted to use a left arrow for assignment. A becomes A plus 1.
I remember.
You don't remember Ruttishauser, you're not that old, yes.
I have seen that.
Yes. And he couldn't have a left arrow, so he had colon equals. And that was the standard in most theoretical computer science, Algol, Cambridge Programming Language, BCPL, from which Cambridge Programming Language was developed and so on. And then Martin Richards went to Bell Labs and they started C. And therefore there were two traditions. There was the Algol 58, Algol 60, BCPL tradition of colon equals for assignment and single equals for equality, the equality test. And there was what you might call the Fortran convention of equal sign for assignment. And what they did when they were designing C was they measured programs. And they realized there were more assignments than there were equality tests, so that should have the shorter symbol. The same reason as the laziness of typesetters I mentioned earlier. The laziness of people typing their programs caused us, I think, to use the wrong symbol today. Because it saved bytes on the computer when C was first developed in 1970. They actually made a conscious decision to use the equal sign, not colon equals, which I think was a mistake in notation. So thank you for reminding me of that as well.
Okay. Thank you very much for the presentation and for the interview as well.
Thank you.